4G, how to use a compass and a protractor. This is a protractor. It allows you to measure angles and draw angles. Let's look at how to use it to measure an angle. Here is an angle labeled ABC. We've been asked to provide the measure for angle B. To do so, we'll use a protractor. Here's a protractor. To measure the angle, slide the crosshairs found midway across the length of the protractor to the vertex of the angle you'd like to measure. Once the protractor is in place, you'll notice that there are two sets of numbers, one going clockwise from 0 to 180, while the other set goes counterclockwise. We will read the scale that has a 0 touching an arm of our angle, so we're using the blue scale. If you look closely, the reading is pretty close to 33 degrees, but we can predict the space between the two markings and I estimate it to be exactly 33, so my reading is going to be 33.0. Our uncertainty would be 1/2 the smallest graduation, so plus or minus 0.5 degrees. This angle doesn't have a horizontal arm, but no problem. Let's bring in our protractor and move the crosshairs to the vertex. Then we're going to spin the protractor so one arm of the angle lines up with one of the zeros on the scale, like so. You can turn it either way and the measure will be the same. Now take your reading beginning from the 0 touching one of the arms. This time we're using the black scale. Our reading looks like 51.5 degrees with an uncertainty of 0.5 degrees. This is a compass and it allows for us to figure out direction. Essentially, a compass is two protractors joined together, like so. Let's measure this arrow that represents a velocity vector. Now remember, vectors have magnitude or size and direction. First we use a ruler to measure the length. Let's assume 1 millimeter equals 1 meters per second. Let's move the ruler in place and measure the length of the line. It looks to me that the line is roughly 67.0 millimeters, or 67.0 meters per second. Let's ignore uncertainty for now. To measure the angle, we'll bring in a compass. A compass always points north. Once you determine the direction of north, the compass itself stays pointing in that direction. Usually, north is up on a map or on a piece of paper, but it's not always. In this case, we're going to use up as north. We'll slide the compass in place so the center of the compass lines up with the end of our arrow. Now read the angle measure either from the vertical or the horizontal arm of the compass. So in our case, we can measure from north arm or the east arm. We're going to determine the direction by reading the numbers on the compass, which might require some math. Conversely, we could slide in a protractor at this point and measure the angle, but this one's pretty straightforward. We'll read our direction from the east arm and see that the vector line creates an angle of 45 degrees towards the north arm. We read this angle as 45 degrees north of east. The vector should be 67.0 meters per second, 45 degrees north of east. We can also read the compass starting from the north arm. In this case, we would be moving 45 degrees east of north. So it's permissible to say that the velocity vector is 67.0 meters per second, 45 degrees east of north as well. In this example, we're going to draw a vector. The vector is a force vector with a measure of 35 newtons with a direction of 62 degrees west of south, or if you like, 35 newtons with a direction of 28 degrees south of west. Here is a compass. If we need to draw this vector line at 62 degrees west of south, you can see that it belongs in the third quadrant. We're going to bring in a protractor to make the measurement a little bit easier. We're going to line up the protractor so one of its zeros matches up with the south arm. We're now going to draw a line 62 degrees west of the south arm of the compass. I'll draw it in green. Now we're going to move the compass and the protractor out of the way and bring in a ruler. Let's decide that 1 millimeter equals 1 newton. We need to make our 62 degree line 35 millimeters long. So move the ruler in place and draw a line over top of your green line 35 millimeters long. If we move the ruler out of the way and erase our green line, we now have a line representing a value of 35 newtons of force with a direction of 62 degrees west of south.